Hello, today's lesson is going to be solving equations. It's 1.3 from your textbook, and we're going to get started right off the bat with a couple of examples. Our first example is asking us to write an algebraic expression to represent each verbal expression. And so here we have the first part, A, 2 more than 4 times the cube of a number. When you are doing expressions in math, it is important a lot of times to kind of read it backwards. So we want to start with the end of the statement, cube of a number. So for a cube of a number, we're just going to go ahead and say that number is x. So we have x to the 3rd power. That's what a cube of a number is. Then we kind of go forward a little bit, and we have then 4 times the cube of the number. So we're going to go 4 times x cubed. And then it says 2 more than that. So we're going to add 2. And that is how we get our algebraic expression for the first part. So now the second one says the quotient of 5 less than a number and 12. And I want to remind you that whenever it says something like the quotient of, the difference of, the sum of, the product of, whenever you have those kinds of phrases, it needs to be 2 items. When you have a quotient, that means division. And so when you're dividing, you have to have, we know we're going to have division, but you can't say the quotient of 5 because you need 2 parts. It needs to be the quotient of 5 and something else. So I just want you guys to be really careful with that when you see the quotient. Look for the word and, because that's going to tell you where the 2 things are. So there's a quotient of 5 less than a number. So that's the first part. There's no and yet. 5 less than a number. So how do we get the 5 less than a number? Again, we're just going to go ahead and call the number x. And 5 less than that number is minus 5. So that's the first part. You have a quotient, and that's the first part. And then here comes the word and. And what? 12. So those are the 2 things that are being divided. So x minus 5 divided by 12. Or if you don't like the division bar symbol like that, you could say x minus 5 divided by 12. And that would be your solution for that one. So that's the first example. Now we have you can do this one by yourselves. And then once you've done that, you can move on. So here's example 2. In example 2, we're going to go backwards. We are now going to be writing a verbal sentence that represents the equation. So we want to go backwards from what we were just doing. So let's see here. We have a product. We have 6x. So we're going to say the product. And this is not the only way to say this. You could say 6 times a number. But I'm going to do the product of a 6 and a number. And you can see from this what I was talking about earlier, about whenever you see the word product or quotient or sum or difference of, it's got to be 2 things. So there's a product of 2 things, 6 and a number, and the number being the variable x. When we use the word equal, or sorry, the symbol equal in math, we use the word is. So the product of 6 and a number is 72. And that would be your expression for part A. Alrighty then. And then for the last one, we're going to do the same thing. We have a sum here. And again, we're adding 2 things. So we're going to say the sum, that's for the addition, of a number. And that'll be our and variable there. A number and 15. So the sum of a number and 15 is 91. All right. Again, you could also write something like a number increased by 15 is 91. And then you could avoid doing the sum of. So it's not the only way to do this, but it is a way that will work. So there you have it. That is example 2. And so then you will do it yourself, number 2. Same idea. And then we will continue. So right now, as we continue, the first thing you want to do is probably pause the screen so that you can write down these properties. You'll need a reflexive, symmetric, transitive, substitution. I have some symbolic representations for you. Assuming that A and B are real numbers for all of these, we're assuming that A, B, and C are all real numbers, then these statements hold true. The reflexive property kind of reminds you of a reflection in the mirror. A equals A. When you look in the mirror, you see yourself. So A equals itself. So that would mean that something like B plus 12 would equal B plus 12. Symmetric property is a little bit backwards. It says that if A equals B, then B equals A. It's kind of reverse the direction of the roles there. That means that if 18 equals negative 2n plus 4, then writing it as negative 2n plus 4 equals 18 is the same thing. Transitive is kind of like, it reminds me of the word transfers, like something transfers off to you. So if A equals B and then in turn B equals C, you can kind of get rid of the middleman and then you have A goes to C. That's kind of like saying if I'm older than you and you're older than a smaller sibling, then obviously I'm older than that sibling. But here we go mathematically, if 5p plus 3 equals 48, and in turn 48 equals 7p minus 15, then the original expression, 5p plus 3, would also equal 7p minus 15. So it kind of gets rid of the middleman. And then we have substitution, and with substitution, if A equals B, then A may be replaced by B, and then of course B may be replaced by A, hence substitution, that they both will work. So here we have, if in parentheses 6 plus 1 times x equals 21, since we know that 6 plus 1 is the same thing as 7, we can replace the 6 plus 1 with a 7, and so therefore 7x equals 21. And that's the substitution property of equality. And we use these properties all the time when we're solving equations. So the first thing we're going to do is make sure that we understand how those properties work. So the first example says, name the property that is illustrated by each statement. So here we have our first one. If 3a minus 4 equals b, and then in turn b equals a plus 17, then we've kind of gotten rid of the middleman. And so we have the first expression, 3a minus 4 is equal to a plus 17. And I hope that you recognize that as the transitive property of equality from earlier. So transitive property of equality. And you don't have to write the whole thing out, just transitive is fine. Sometimes you can write trans, and that'll work just as well. And then we have in part B, if 2g minus h equals 62, and we know that h equals 24, then 2g minus 24 equals 62. And I don't know if you noticed it or not, but here's your h, and we know that h is 24. And so in this expression, everything is the same as the original, the 2g, the 62, except for the h part. The h was replaced with 24 because h is equivalent to 24. That is called the substitution property of equality. Now with substitution, it's probably going to be important that you actually write out the word substitution, because if you don't, if you put like sub, for example, someone might think that you're writing subtraction, and it's not subtraction, it's substitution. So you want to make sure that you at least write out the substitution part. All right, so now you have this one to do. There actually is no B, it's just this one, so there you go. And this is the addition and subtraction properties of equality, and the multiplication and division properties of equality. And so basically, again, A, B being real numbers. If A equals B, then adding a number like C to both sides would still keep the expression equivalent. So A plus C would equal the same thing as B plus C, and the same is true if you subtract a number from both sides, it would still be equivalent. And then with multiplication and division, same idea, just one extra stipulation. Because of division by 0, we assume that the C cannot equal 0, okay? But otherwise, if it's not 0, then if A equals B, then multiplying both sides of an equation by the same C value still keeps it equivalent. Dividing both sides of the equation by the same C value also keeps the equations equivalent, provided that the C does not equal 0. So you write those little guys down, and we are going to apply those properties here. In example 4, we want to solve this equation. These are one-step equations. We also have multi-step equations, but right now we're going to get started with one step, just kind of trying to warm you up to solving equations again. So because we have a minus 3.24, we're going to use the addition property of equality, which says that we can add the same value to both sides, and we will still keep or maintain equality. So we get the n, because negative 3.24 plus 3.24 is 0, they basically cancel. And then we get the 42.1 plus 3.24 will be 45.34. So, but also what they want us to do, it doesn't just say solve the equation, it says actually check your solution. So what we want to do for that is go back to the original, which was n minus 3.24 is supposed to equal 42.1. And since in our problem our answer was 45.34, I am substituting the n value from the original equation, the original expression, and replacing it with 45.34. And then I'm going to go 45.34 and subtract 3.24, and it is in fact 42.1. So you want to check your solution, make sure that you're correct, okay? So now we have part B, another example here, and we have negative 5/8x equals 20. Now I want to let you guys know, just in case you're wondering, that negative 5/8x is the exact same thing as writing negative 5x divided by 8 equals 20. A lot of people don't realize that, but you can very easily multiply across. Negative 5 times x is negative 5x, and 8 times 1 is 8. So they are in fact the same expression, just in case you didn't know that. It is useful information sometimes. But right now, we want to solve this expression, and the way that we're going to do that is by multiplying. We're going to use now the multiplication property of equality, and we're going to multiply both sides by the same value, and we're going to multiply by the reciprocal of the fraction. So this is 5/8, so we're going to go 8/5. Still going to be negative, because we want a negative value there, so that when we go negative times negative, you get positive. So 5 and 5 cancel, 8 and 8 cancels, negative times negative is positive, and you're left with x. So when you have a fraction, you want to multiply both sides of the equation by the reciprocal of that fraction. Okay, so then we have 20 times negative 8/5. And the easiest way to do this to avoid using really big numbers is to realize that when you have the 20 and the 5 here, you can reduce those from the right off the bat. So 5 goes into 5 once, 5 goes into 24 times. And now instead of going 20 times negative 8, it's actually asking you 4 times negative 8, which is negative 32. And then you would divide that by 1, because on the bottom you have this 1 here. But of course, we know that dividing by 1 is the same thing as negative 32. So our final answer is x equals negative 32. So we want to go back to the original expression, negative 5/8 times x, and it's supposed to equal 20. And in this case, our answer that we got was negative 32. And we want to see if that works. And again, we can use reduction. We know that 8 goes into itself once, 8 goes into 32 4 times. And so negative 5 times negative 4 is in fact positive 20, and we have checked our solution. So that is how you do those problems. And now you can try these do-it-yourself problems by yourself. Don't forget to check your solution. And then we're going to move on to example 5. Example 5 is going to be more of a multi-step problem. It's not going to be solved with one step like the last ones. And so one of the things that you have to recognize when you're looking at this is that we have to combine the x values together. And there's an x value in here, and there's an x value there, and they're kind of trapped inside of those parentheses. So before we can even try to combine like terms, because as you know, when we're solving equations, you want to isolate the variable. But in order to isolate the variable, you need to combine the x's together. And we can't do that because of those parentheses. So that's our first priority right now, is to get rid of the parentheses, and we're going to use the distributive property to do that. So we're going to go 5 times x plus 5 times 3, so we're going to distribute the 5 there, and then we're going to go plus 2 times 1 plus 2 times negative x equals 14, and that's our first at the distributive property. Then we'll simplify this to 5x plus 15 plus 2 minus 2x equals 14. And now we can combine like terms, so we can take our 5x's and our negative 2x's and call that 3x's. Another common mistake people make is that they try to combine the like terms and they try to add the 2x like this. This is wrong. You do not do the inverse or the opposite unless you are actually doing it to two sides of the equal sign. So as you can tell right now, I am not adding 2x to another side. Here's the side. There's my equal sign. I'm not adding anything to the 14. So this is actually wrong. You do not want to do that. So when you are on the same side of the equal sign, you just combine the like terms. Another way of looking at it is to do kind of backwards distribution, where we're taking 5 minus 2, the coefficients of the x's, like this, but again, 5 minus 2 is 3, so either way you get 3x. But again, do not add the 2x to the 5x, do not subtract the 5x to the negative 2x, just simply add those two together. Same is true here. 15 plus 2 is 17. All right, so now that we're, like I said before, we're trying to isolate the variable. We've got the x's together, but now we need to move the 17. So you can see the difference now. See, now I am doing the opposite, but that's because I'm going to move it to the other side. I wasn't moving the 2x to the other side. I was just moving it further down over here. So now we're actually moving it to the other side. So now it is important for you to actually do the inverse. So that gives me 3x. 14 minus 17 is negative 3. Divide by 3 on both sides. And x equals negative 1. And just like that, you've solved your multi-step equation. All right, so now you can try these bad boys. And then we'll do our last example, which is probably one of the scariest. Not that I'm trying to scare you. I'm not. I just know that when you see a bunch of words, sometimes you want to go hide under a table. So please do not go hide under any tables. And this example is one that we see a lot. They're giving us a formula, the formula for the area A of a trapezoid. I've got a little diagram for you over here in case you've forgotten what a trapezoid looks like. And here is the area. It's equivalent to 1/2 times the height times the two bases added together. So it tells you here that H represents the height and that B1 and B2 represent the measures of the bases. You can see in the diagram, here's the first base, here's the second base, and then we have our height, okay? But what it's asking us to solve the formula for B2. And this is actually what caused people some problems. So I'm going to rewrite this formula with the exception that I am going to put the variable in question in red. Okay? So the reason why this kind of, freaks some people out is because you don't have a lot of numbers, you have a lot of variables. And whereas the last example, you had only one variable, it was the x variable. Everything else was a number, and so you were pretty confident with what to do with numbers. But now you have a bunch of variables, and for some reason students tend to forget, and they think that because it's a letter that you can't do what you normally would do with a letter that you can with a number. But you have to remember that in general, the letters are representing numbers. And therefore, whatever you can do to a number, you can do to a letter. So the reason why I'm kind of making the B2 in red is so that it can stand out from all the other letters. And now this is my variable. B2 is my variable. So I know that normally we consider any letter a variable. But for this situation, we're actually going to only treat B2 as a variable. And everything else is just going to become a regular number. And so basically what we want when it says to solve the formula for B2 is we want to isolate the B2. We want B2 to equal something. In the end, the answer should say B2 equals something. What does it equal? We have to move everything around here to get B2 by itself. So again, in order to do that, you should recognize, like earlier, that the B sub 2 is trapped inside of the parentheses. So in order to get it out, we're going to have to deal with this here. So the first thing I'm going to do is, I don't like this fraction, okay? So I am going to multiply both sides of my equation by a 2. And the reason why I'm going to do that is because 2 times a half is 1. So off the top, I'm going to get 2a equals, instead of having 2 times a half, I'm just going to get h times b1 plus the b2. Okay? But the b2 is still trapped. So now this h, I got rid of the fraction, but now this h is out here and these parentheses are still there. So we don't want those parentheses. So we are going to distribute h times b1 plus h times b2, if you will. Okay? And then we're going to simplify that. So we're going to get 2a equals b1h. I do that because I want them to be in alphabetical order. B comes before h. And then we're going to do b2h. Okay? And then the last thing we're going to do is, not the last thing, but one of the things that we're going to do now is we want this b1h to kind of go to the other side. And we said earlier that when we do that, we have to do the opposite. So we're going to subtract b1h from both sides. All right, and we're running out of space there. So I'm going to come on over here and we're going to rewrite what we have so far. We have 2a, and we've subtracted b sub 1h, and that is now equal to b2h. All right, so that's what we've got so far. So we're almost done now. The only thing that's still over here, that b2 is still not isolated. It's not by itself. The only thing that's still hanging around is the h. So we want to get rid of the h. So divide both sides by h. And now we can say that b2 is actually equal to 2a minus b1h all over h. And that would be our final answer. So again, what I hope that you got from the example was that you need to know which variable they're asking you to isolate. They're asking us in this case to isolate b2. So then that variable is the one that becomes important, and everything else just gets treated like a number. So I hope that that has been helpful to you. We have one more do-it-yourself for you. It's another formula. Have a little diagram for you. And this time you're solving for h. So remember that h is going to become the variable and everything else gets treated like a regular number. Good luck with that. Once you've done that, you will have completed your video, and I will see you in class.